Next thing that happens is remember that our inactivation gate is going to close a certain time after the activation gate has opened, right? So our activation gate has opened. It stays open for a little while, and then the inactivation gate is going to move in and close off the channel. Okay, so what's the result of that? Take a moment to answer that question. Okay, so hopefully you were able to determine that when we are blocking off the channel, we no longer have sodium flow through the channel, right? There's not a path for sodium to go through. Sodium's going to stop going through, and that is partially what is responsible for the repolarization or the falling phase of the action potential. Oh, sorry, this is a little too far into the future. Let's stay here. Okay, so membrane potential is going to come back down because sodium is no longer coming in to depolarize the membrane. Also remember that the other thing that's happening that's not shown here in this diagram is that potassium channels are opening, and that is also bringing the membrane potential down, okay? All right, and then finally, sort of at the end of the action potential, these gates are going to slowly return to their original positions. Okay, so just to recap those steps, I want to remind you, we're starting at resting membrane potential. At resting membrane potential, the activation gate is closed. We're going to depolarize the membrane. That is going to cause the activation gate to open. That's going to allow sodium to come into the cell and depolarize the membrane some more. After a while, the inactivation gate is going to come in and close off that sodium channel, thereby prohibiting sodium from crossing the membrane. And then finally, eventually, we're going to get our falling phase of our action potential, which is partly due to sodium not being able to come into the cell, but is also due to potassium leaving the cell. And then finally, we're going to get back to our resting membrane potential, and the gates are going to reset. Okay. So here's a question for you. What is the action potential going to look like if there weren't an inactivation gate? What would the action potential look like? So take some time to think about that, hit pause, answer that question on your worksheet, and we will talk about this in class. Okay. All right, so we just finished talking about the properties of voltage-gated sodium channels. Now let's talk about the voltage-gated potassium channels that are also a big player in the action potential, okay? So as you already saw, voltage-gated potassium channels are slower at opening and closing than voltage-gated sodium channels, right? So just looking here, sodium channel is opening quickly, closing quickly. Potassium channel, which is in purple here, is taking a longer time to open, taking a longer time to close, okay? Potassium channels, these voltage-gated potassium channels, they have an activation gate, but they don't have an inactivation gate. Okay, so basically the activation gate is just sensitive to voltage. Once you reach a certain voltage, once you depolarize the membrane a certain amount, those channels will start to open. Okay, and then once you fall below that range of membrane potential, then that activation gate is just going to close again. Okay, so that activation gate is just behaving in response to the membrane voltage, membrane potential, right? If it gets up to a certain level, it's going to be open. If it's below that level, it's going to be closed, okay? So that's basically it. So thinking about how that fits into the action potential, right? We start to depolarize the membrane here. That's going to be what causes the potassium channels to open, okay? But remember that we have the falling phase of the action potential, which is actually due to potassium moving out of the cell, partly, okay? That's going to bring the membrane potential down. And once that membrane potential comes back down to this area right here, that's going to cause the potassium channels to close again. All right. Okay, so that basically concludes our discussion of the ion channels that underlie the action potential. I have this slide here to remind me and you that there is this lovely video that shows how an action potential is generated, what's happening with the ion channels during the action potential. It's a really great animation. Please watch it. I'm going to have that on the list of videos for you to watch, okay? And then here are your learning goals and your vocabulary for this section.